Alright, welcome back ladies and gentlemen. We're talking about 6.1 Law of Sines. Now chapter 6 as a whole is basically about non-right triangle trigonometry. So basically what we're going to do is adapt the trigonometry stuff that we have so that we don't have to work with the right triangles that we're used to. Also we're going to go back to degrees, so for those of you that struggle with radians and things of that nature, you can kind of put that on hold for a while. Additionally, we're going to throw some vectors and things and kind of some physics-based application in the chapter as well, but the bad news about this whole thing is these first two sections that we're going to cover, law of sines and law of cosines, it's going to be very, very important that we get this stuff straight because the rest of the chapter is going to hinge on it. So let's get rolling here. Alright, so for the law of sines, we're going to solve problems using the law of sines. Okay, we've got a naming convention that we have to deal with here for triangles in general. Okay, so as we're doing this, all angles are going to be named with uppercase letters, like how I did that. Isn't that fun? Alright, so again, if I have a triangle down here, maybe I'll call it triangle ABC. So capital A, capital B, and again, handwriting dependent here, but capital C is going to be really big. And as we measure, do side measures labeled with lowercase letters, okay, A and B is pretty easy to tell apart. But again, depending on your handwriting, a capital C versus a lowercase c can look almost identical. So depending on your handwriting, you might want to exaggerate the capital and the lowercase c so it's apart. But then I've kind of already done opposite sides and angles share the same letter. So these opposite side, opposite angle here, those are both C's, capital and lowercase. And then since this is uppercase A, I got to go across the triangle to get lowercase a here to represent the side measure. And then of course here's B, and then across from it, opposite it, using the proper geometry word. There's where our lowercase b would come into play. Okay, there's our assignment, but let's keep moving. Alright, so the law of sines is the formula you see right in front of you there. Sine of angle A over A equals sine of angle B over B. Remember again, the lowercase ones are the side lengths. Equals sine of angle C over little c. Okay, now a three-sided equation doesn't seem to make a whole lot of sense, and granted we're not going to use it as a three-sided equation, it's just kind of the way the formula is written. But basically what we're going to do is, based on the information that we have out of this triangle over here, we're going to take two of these three fractions and then use the formula based on those two parts and kind of ignore the third one. Alright, just for your own clarification, if you look at the book, it writes it reciprocal. Don't freak out, it's not that one of us has it wrong. They're equivalent. It's just, to me, putting an A on top and then the sign of big A on the bottom and then continuing that with the other parts, I don't know. It's just, to me, it looks better with the trig thing on top than having the trig thing on the bottom. For whatever reason, my brain doesn't like that. So basically, I'm going to keep it like this, and I'm the teacher, so ha ha ha, I get to do it the way I want to. But if you want to do it the other way around like the book does, feel free. It will not offend me. Okay, but here we go. Okay, this formula is great because if I don't have a right triangle with our SOHCAHTOA stuff, then we're in trouble. Because it only works with 90-degree angles, hence it's called right triangle trig. But this works regardless if it's a right triangle or not. So it's a nice little flexibility thing that this formula kind of has. Alright, so without a big long explanation, because I'm sure you're just dying to hear me talk for another 20 minutes on this slide, the formula works really, really well. Again, if I'm dealing with two of these three bits, and again, so I'll just ignore the C for a second. Okay, sine of A over A, and then sine of B over B. Alright, so here's the information that we could be dealing with. Alright, and if you think of basically your geometry congruency sort of things, let's again pretend for a second that maybe we don't have the B. Little b that is. So which I've dealt with information-wise, I've got an angle, and then a side. So it deals with an angle, side thing. And without a big long description, because I'm sure you're getting sick of me at this point, angle, side, angle would be the other situation that works really well. Mostly because really if you've got two angles in a triangle, you can use a very, very quick subtraction to find the third one. So really having an angle, side versus angle, side, angle is almost equivalent because all you need is subtract to find the third angle. Okay, but let's see some examples and get that thing working. Alrighty, the law of sines is a really good tool for solving triangles in general, and basically again, solving triangles just means find all the parts that you're not given. Okay, and here we're going to round our final answers to the nearest tenth, but only the final answers. Basically what I mean by that is, if you round your numbers as you're doing your work, trig is really, really touchy sometimes, and a little bit of rounding at one point can generate a very, very large error as you move forward if you do any calculations based on that rounded number. So it's going to be very important not to do any rounding until the very, very final answer. So let's go. Okay, so basically you're given whatever information. You're going to be given 3 of the 6 parts of the triangle. So some combination of sides and angles, you're going to be given that. Okay, notice we are doing degrees now. So again, I said earlier, if you're scared of radians, don't worry about it. They're kind of taking a break. Okay, what I do is I draw a fairly generic sort of triangle, and that's really an icky one, and then I just slap down A, B, C, and then start labeling. It's your decision if you want to try to draw this thing more to scale. For instance, the C being 104, maybe you could have drawn one that's a little more obtuse, or maybe based on this triangle I could have put the C up on top. It really doesn't matter all that much, but again, if you're particular about drawing things to scale, go right ahead and do that. Won't hurt anybody's feelings at all. Okay, so anyway, my big A is 63, so that's an angle. My big C is 104, again the angle, and then my little a is going to be a 24. Okay, so then again I've got this little c over here, and I've got little b over there, and I just need to find those 3 parts that I'm missing. Okay, as kind of alluded to in the other one of the easiest things you can find if you have 2 angles is the third one. So basically all you have to do, for instance in this case for big B, just take 180 and then subtract off the other 2 that you have, 104 minus 63. I know some people like to add these 2 together first and then subtract the result of a 180. Whatever works for you, that's fine. But there you go. Doing that subtraction should give you 13 degrees. Okay. Now I confess, in general, I don't like to use a calculated number if I can help it, because just on the off chance I made a mistake here and I use this 13 in a future calculation, of course the resulting calculation is going to be wrong. So I'm going to stay away from that if I can. Unfortunately, in this case, I'm going to have to resort to it. But whatever. I'll put that guy in red to kind of highlight that he's somebody I didn't start with. But here we go. Okay, now based on what we have here, we can find whatever we want to find. Again, just kind of sticking true to the old, I don't want to use something that I calculated myself, just in case I made a silly mistake. Okay, I'm going to go with finding a little c right now, because I'm given kind of my entire a fraction. So I've got sine of 63. Pardon me for skipping the degree symbols for a lot of this. It gets a little tedious sometimes. 24 on the bottom. And then again, I want to use the c fraction. So I'm kind of ignoring b altogether here, doing sine of 104 degrees over the little c. Okay, now at this point again, as I said earlier, this is basically a cross multiplication problem. And your degree of flexibility and comfort with this is your own thing. But I'll show all the steps here for the sake of argument. So cross multiplying, I get c times sine 63. I caution you, don't put the sine 63 first and the c later, because then it looks like the c is part of the angle measure, and I think that leads to mistakes. Likewise, I'm going to put the 24 first and the sine of 104 separately to again completely make sure that the 24 isn't involved in this angle measure at all. Okay, now I could get some decimals right here, but just for the sake of having something I can type in my calculator all at once, I'm going to divide off the sine 63 right now and have little c equals 24 sine 104, all divided by sine 63. Okay, again, punching in my calculator, it spits out a decimal of 26.135 and goes on for quite a while. Okay, but again, I'm just going to round to the nearest tenth, so really just 26.1 is going to be my little c. So I'm putting 26.1 over here in kind of an answer box that I've made for myself. Okay, now one thing you might want to go with now is, well, hey, I've got a triangle and I've got 2 sides. I got a 24, I got a 26 and change, so hey, maybe I could use the Pythagorean theorem. Okay, hopefully you're not thinking that though, but if you were, I forgive you. The problem is the Pythagorean theorem only works on right triangles, and since we don't have one here, we definitely can't use it. Okay, so Pythagoras, I'm sorry, he's going to have to take a break. Okay, so really I have no choice now but to go with the law signs again, using that calculated b. But again, this was such a clean calculation that I don't really feel too bad about having to use it. Okay, and another choice I could make right now is I could use the c and use my c fraction, but again, this 26.1 is a messy decimal, and again, it's another thing that I calculated myself. So for those 2 reasons, I don't want to use it, because just in case it might cause me to make some mistakes or have my answer just be a little bit off. So I'm going to stick with the a fraction, since that was comprised totally of given information. So sine of 63 over 24, I'll put that on the bottom. And then, again, like I said, I have to kind of bite the bullet here and go with sine of 13 and put that on top of my lowercase b. Okay, now doing basically identical cross multiplication steps, I eventually should get to b equals 24 sine 13 over sine 63. And you might be looking at that and saying, hey, that looks pretty identical, and yeah, it is. The only difference is I have a 13 here instead of the 104 in the last one. So if you're good with your calculator, you just kind of edit the last entry and let it do the work, and this guy should spit out a 6.059, and again some other decimals, rounding to the nearest tenths, gives me a 6.1. And now my triangle is solved. There's all the information, and that's basically how you do it. Alrighty, let's do another one. This has a slightly different setup for it, so here we go. Won't be too shocking compared to the last one, but here we go. Again, draw first of all a very bad triangle. It's important that's a terrible triangle. If you draw a really nice triangle, you're going to have to start over. Alright, but anyway, I've got an angle, again, just my very generic ABC. I don't know angle A, but I do know side A, which is 14. Okay, I got angle B, which is 49 degrees, and then side C is 33 degrees. Okay, again, now here's my angle side angle setup. But again, pretty simple once I have two angles to find the third one and kind of manufacture my own angle side, which is a little more user-friendly for this formula. So really, I view them as pretty much the same thing. But here we go. Okay, so first thing first, I don't have angle A, although that is an easy one to figure out. 180 minus the 49 minus the 33, and that works out to be a nice clean 98 degrees. So there you go, 98 degrees. And again, unfortunately, I don't have like a whole fraction up until that 98 degrees. I only had half of the B information because I had the big B but I didn't have little b. I had big C but I didn't have little c, and I only had half of the A fraction as well. So up until that 98 I couldn't use the law of sines. So unfortunately, even though that is one thing I calculated myself, it's the only way I can start using the law of sines here. So I've got to rely on myself to have done that subtraction correctly, and I can go from there. So now sine of 98 over 14 gives me my whole A fraction. And now I can either find B or C. Just for alphabetical sake, I'll do the B first. So sine of 98 over 14 is going to equal the sine of 49 over the B. And again, after doing that same little cross multiplication thing we did last time, we should eventually get B equals 10 point, and our calculator will spit out 669 and a whole bunch of other stuff. So of course we can round that to 10.7. Alright, and then basically just repeat the process from there. Again, you can't use the Pythagorean theorem because we don't have a right triangle. And then do the same thing with C. Again, my best fraction is my A fraction, sine of 98 over 14. Again, if I try to use the B one, I'll have to use this decimal-y thing in there, and it's just awkward, so let's skip it since we don't have to deal with it right now. So sine 98 over 14 again gives me sine then of 33 over C, again doing a little cross multiplication, eventually gives me 7.6998 and a whole bunch of other stuff. And again, a little bit of rounding gets me to a 7.7. And so basically there's where the angle side angle starts, and with a simple subtraction you've got yourself in a position to start using the formula, and you can find the rest of the information that you need. Alright, so one really cool sort of thing is using the law of sines you can derive an area formula for triangles. And it's kind of just like the law of sines, it's kind of a three-sided sort of thing, but don't freak out on this one, because really it's just area equals 1/2 AB sine C. Although, depending on which angle you have, you can rewrite the formula based on the other two sides. So really it looks like this big scary thing, but basically what it equates to is what it says here in green. The area is half the product of any two sides and their included angle. So it's not really something you have to memorize three different ways. You just memorize this little green thing, or at least understand that little green thing, and everything comes into play pretty well. Alright, so basically, here we go. Let's use a right triangle here. If we've got this sort of setup, okay, well, given it's a right triangle, so heck, if it's a right triangle, I know area equals 1/2 base times height. Okay, well, area here, alright, and I'm going to spell out the word area because sometimes using big A gets confusing with some other big A's that we might have, and that can get kind of crazy, and we don't want to do that. Okay, so anyway, 1/2, okay, the base of this guy is the 12, and the height of this guy is the 5. Okay, and again, the 13 is irrelevant for the area, at least. So area equals 1/2 times 12 times 5. Okay, 1/2 times 12 is 6, times 5 is 30. So then it's 30 units squared. Whatever kind of square units we have right there, we got 30 of them for this area. Okay, well, if I'm going to use my trig formula here on this, okay, notice that I need two sides and I need an angle, and that angle's in between them again. If I've got A and B, the angle in between them is C. Alright, so that's true if you do the other two as well. I'm not going to waste your time and do it right now, but there we go. So basically, let's go with one of these. I'm going to find this angle down here, so let's call that guy theta or something like that. So basically, I need to use any two of these sides, and I can use any of the inverse trig functions I want. Let's use tangent just because it sounds fun. So basically, tangent of theta is going to be 5/12. So again, what that basically means is theta equals the inverse tangent of 5/12, and punching that in my calculator gives me a theta of 22.61 etc. degrees. So 22.61 and a whole bunch of other decimals. But again, I'm just going to leave that in my calculator so I can use it in just a second. So since I'm looking at a 22.61 degree angle right there, it's kind of hard to sell that probably, but you know what I mean. It's right there. Alright, now I can use my formula. Okay, so again, I don't even care about ABC, whatever. I care about an angle and the two sides that are next to it. So the 12 and the 13 are the ones next to this 22 degree angle. So now my area is going to equal 1/2. There's actually an E right there. It's hard to see. Okay, 1/2 times, well, the two sides. And I don't even care about the order since I'm multiplying. So I'll just say 12 times 13. But I do need to use sine. Okay, I know I use tangent there, but who cares? The formula has sine in it, so I got to keep using sine of that 22.61 icky decimal that I just had. And again, typing that in your calculator, believe it or not, gives you a nice clean 30 out of it. So again, it's still 30 square units. Okay, I challenge you to actually do those calculations yourself just to see that I'm not making up stuff and lying to you, because I have been known to do that. Not really, but you know what I mean. Alright, anyway, so there's how it works on one that we knew the answer was, so let's do it on one that we don't know the answer in advance, and keep going from there. Alright, so here's 3 bits of information about a triangle, and our directions here are going to be to find the area. Okay, well, again, first thing I think is a good thing to do is draw a very bad triangle, ABC, and label what we know just to make sure we're looking at the right information in the right sort of sequence. Alright, so I've got a 13.7, a 53 degrees, 17 minutes. Okay, so notice kind of in the thing I'm doing here is, hey, remember where you can do the degrees and minute symbols on your calculator because it might be important. And then the 24.5. Okay, now the area formula is based off of having two sides in the included angle, which is what we have here. Okay, I bring this up because, you know, it is obviously possible to give you not the exact bits of information you want on some other sides, and then you might have used some of that solving triangles sort of stuff that we did to find a missing angle or sides as appropriate to get the stuff in the right sequence or order, whatever. So anyway, fortunately we're lucky enough here to have everything in the right order and the right parts that we want. So all we need to do is say area equals 1/2, and again I caution you against using A for area because A could easily be confused as an angle measure, so be careful. So 1/2 times the 24.5, just one of the sides, and again it doesn't matter what order you do the sides in. And then sine of, and again just basically make sure you know where all these buttons are in your calculator to put in the 53 degrees, 17 minutes. And then basically just press equals, because notice there's no letters over there. Well, there's the trig ones, but there's no variables, you know what I mean. Alright, so the calculator should spit out 134.528 and a whole bunch of other icky decimals. And again, sticking with my rounding to the nearest tenth theme, this will be a 134.5. And again, since we're talking area, we're talking about square units. So there you go. That's how that formula works. Again, caution, know where all the calculator buttons are, and make sure that you're dealing with the right information in the right order before you jump into it too deeply. But there it is. Of course, if you have any questions, be sure to ask me in class. See you then.